All right. So this is another type of and problem. I like to call it, oops, sorry. I'll zoom out. Actually, let me make this bigger. Is that good? Okay. So the other type of and problem that we see is one that comes in the form of what I like to call and sandwich. Okay. And it looks like a sandwich because you have two inequalities. You have something in the middle, two inequalities, and then stuff on the outside. So it kind of sandwiches the middle. You're sandwiched by two different inequalities, right? Which you see here and here. Okay, so technically what it is, it's two different inequalities, but these are always and inequalities. Whenever you see it this way, it's an and inequality, okay? All right, so here's what we do. It's pretty simple. You kind of just solve the way you would an equation, except now you kind of have like three sides, right? You have left, middle, and right. So what your goal is to get the x by itself that's in the middle, right? You want the middle to be by itself. You just want x in there, all right? So here's what we can do. The first thing is, well, if we wanted to get x by itself, what would we have to get rid of? The 3, right? So we would subtract 3, but you would do it not only from the middle, but you would do it to the left and then also to the right, okay? So then what we get is 3 minus 3, that cancels, right? Now you're just left with negative x in the middle. You can bring down the inequalities. You have negative 2 minus 3, so that's negative 5. And then 4 minus. All right. Now we're not quite done yet because x needs to be alone completely. It's a negative x at the moment. So we would either have to divide everything by negative 1 or multiply everything by negative 1. Okay. So here in this case, let's divide everything by negative 1. Okay. All right. So now negative over negative, that makes this a positive x. 1 divided by negative 1 will be a negative 1. And negative 5 over negative 1 is just 5. Okay. But since I divided by negative, what should I do to both inequalities? Yeah, we flip, right? Flip. So instead of pointing to the left, now it goes to the right and the other one as well. All right. So there is our new inequality. Okay, which part? Negative 1 part. Okay, so you see that I divided by negative 1 because x was negative x. I want x to be positive, right? I want x to be alone. So in order to get rid of the negative, I had to divide by negative 1. Yeah, right? Think about it as like a negative 1 right here. So then I divided by negative 1. But if I divide by negative 1, I got to do it to all sides, right? And since I have like 3 sides now, I have to do it to the left, middle, and right. Okay. And then since we divided by negative, when we had to flip the inequalities. Okay. So that was the rule that we saw last. Does that make sense? Does that help? All right, good. Okay, so now here's our inequality, right? And we have one that's basically sandwiched in there. But I basically have two inequalities in one. So I want to make sure that I read this correctly, okay? I want to kind of pull it out here. And if you notice, this is like my first inequality right here. I have something that says 5 is greater than or equal to x. And then my other inequality is the second one right here, kind of borrowing x one more time, where it says x is greater than negative 1. All right. So once again, I have one inequality that's pretty nice and easy. X is greater than negative 1. But the other one, this is the one where you might want to do the flipping around yourself to make it a little easier, right? So here, this is where we can say x goes to the left, 5 goes to the right. And then since this inequality was originally pointing to x, we want to go ahead and reverse it, make it point to x still. All right? Okay. So there we go. Now we can go ahead and put this on a number line, and let's go ahead and graph. And let me make this a black number line. So here are my two key values. I have 5, positive 5, and then I have negative 1, and then I have 0 somewhere in between. Okay. So I think we're going to get something similar to what we got previously. Okay. I think it's just that the problem looked different, but we might get a similar scenario. All right. So at negative 1, we have an open circle. And this reads right here, x is greater than negative 1. So when we're greater than negative 1, we shade to the right. Okay, so let's shade to the right here. Okay, the next key value is 5, right? So at 5, we have a closed circle. And we want to go ahead and shade this time to the left since x is less than, right? X is less than 5, so we shade to the left of 5. Okay, once again, because this was an and problem, you know it's an and problem because it comes in a sandwich, right? When you recognize a sandwich, you know it's an and problem. So when you're looking for and, you're looking for the intersection, right? Where are the areas that the shaded regions overlap, right? So once again, it ends up being in the same spot as the previous example, right? We have overlapping red here, right? In between negative 1 and 5, okay? So then that lets us write this interval, right? Between negative 1 and 5, okay? So in between 5, I'm sorry, to the, at 5, because it's a closed circle. Yes, exactly. Yes, this is a feasible region, okay? Feasible region, also known as your solution set. Okay, so the solution set exists in between negative 1 and 5. At negative 1, once again, that was an open circle, so we would use a parentheses. And then at 5, that's a closed circle, so we use a bracket, okay? Any questions so far? Okay, so then we'll try, we'll do one more example and then I'll give you a chance to try one on your own, all right? So let's go ahead, go on to example number. This is kind of combining some of those skills that we learned earlier, right? So we looked at solving equations, we looked at solving inequalities, now we're looking at compound. You see the two inequalities there, so what kind of type of inequality is this? Is this and or is it or? Yeah, this is the and, right? This is the and sandwich. You can see the two inequalities are sandwiching the middle expression, okay? All right, so a couple things. First of all, I see a 3/4, all right? So I don't want to deal with a fraction the rest of the problem. So what do we know that we could do to help us get rid of the fraction right now? Step 1. LCD, right? We look for an LCD, lowest common denominator. Since 4 is the only denominator that we have, then we're going to go ahead and multiply by that value to everything, right? We're going to multiply to everything. Okay, so here, my brackets, I'm going to multiply by 4 to the entire equation, okay? Left, middle, and right, okay? That's going to help me get rid of that denominator. So 4 times negative 4 would be negative 16, still greater than. Here, let's do a little mental math. 4 times 3 is 12, and then divided by 4 takes us back to 3, right? So that's just 3m. 4 times negative 7 is negative 28, and 4 times negative 7 is also negative 28 again. All right. With me so far? Okay, so all we did was just a little fraction buster to help us get rid of that fraction so that we don't need to see it over again as we move down the problem. All right, so now I want to get m by itself, right? What do we need to do? Yeah, let's add 28, right? We add 28, that's the 28 we're trying to get rid of. If we do it to the middle, we also do it to the left and then to the right. Okay, so you want to make sure you apply it to all three sides. Good. All right, so now we can bring down the 3m. Here, this would be negative 16 plus 28, so this gives us 12. Negative 28 plus 28 is 0. Okay, so even if you get 0, make sure you bring down 0 because you need to keep the sandwich, all right? Don't like cross it out and then you don't bring anything down and now you're left with just one inequality, all right? So make sure that even if it's 0, you bring that down. All right, and now we divide 3 to all sides, right? We want to get m by itself, so let's divide by 3. Okay. M is greater than 0 and m is less than 4. All right. So you see how I was able to read that, kind of like going from the middle, starting with m, right? I can see m is greater than 0, but also m is less than 4. Okay. So once again, if this is the part that where you run into some trouble, you want to take both of these, kind of separate them into your two inequalities there. Right? So the one in red is easy, right? We can read that as m greater than 0. The one in green, this is the one where you might need to flip, right? So you might want to bring m to the left. Let me keep it in green, actually. M to the left, 4 to the right, and then you flip it back so that the arrow keeps pointing to the m. Okay, so now what we have is m is less than 4, okay, and m is greater than 0, all right? So let's go ahead and put that on the number line. Let's graph it, and then we can write our interval. Okay, so here's 0, here's 4. Okay, let's do colors. Okay, so with 0, m greater than 0, greater than, that means open circle. And then if it's greater than, we also shade to the right. Okay. Now with 4, I'm gonna use green. Okay, so m is less than 4. So at 4, once again, open circle. And less than means we go left. Okay. So here is my overlapping section, right? My intersection. Where is the intersection happening? It's happening right here between 0 and 4, right? We see the red and the green. Both of them share the same space. Okay. So we can go ahead and narrow that down as our interval. We can say, all right, between 0 and 4 is my solution set. At 0, though, I have an open circle, so we have parentheses. And then at 4, another open circle, so another parentheses. Okay. So what we're saying here is that the solution is anywhere between 0 and 4, just don't include 0 or 4. Okay, but everything in between counts. Okay. So there's our solution. Here's our algebra. Here's our graph. And here's our interval. All right. Any questions so far? So far, so good? Not too bad, right? Not too bad. Okay, so now let's transition. I want to go into the near part so to give you a chance to practice on your own. All right. So let's take a look, right? Initially, what you probably did was distribute the negative, right? So you got negative x plus 1 greater than 4. And, right, intersection. So I gave you the symbol this time just to show you that it can appear in different ways. Distribute the negative, now we have negative 1. And then negative times negative would be positive x. And then this is less than 4. So now let's go ahead and solve this out. If I want to get x by itself, first we subtract 1 from both sides. So we get negative x is greater than negative, I'm sorry, just greater than 3. And then if I want to get the x by itself, I should divide by -1 on both sides. That's going to give me x is less than -3, okay, because I had to flip the inequality when I divided by a negative, all right? So that's my first one, okay? Intersection with. Let me solve the other side. So here we add 1, add 1. This one's a little easier, and we just get x is less than 5, okay? So I gave you two different graphs, hoping that you would use both of them, okay? So that you could see how this kind of turns out. Oh no, what happened? All right. So I have my two lines. Here's the first one. Here's the second one. Okay, so here you got to be careful about where you position them because you want it to line up almost, right? So that it makes sense. So if this is, let's say, your -3, and let's say this is your 0 here, and then you put 5 over here, keep it consistent, right? So your 5 is over here, here's your 0, here's your -3, okay? All right, let's do the first one, right? We have x is less than -3. So we have open circle, and then we shade to the left, right? And right now we want to find the intersection with the other inequality. And the other inequality, I'll put this one in green, okay? We start at 5, and it's open circle, right? And we want x is less than 5. So then we also shade to the left, okay? Now you got to stop and think and say like, okay, where is the overlap section happening? Where is there both blue and green, right? So if you start paying attention to where there's an overlap, it's right here. It's in this section right here, right? We have blue and green. And then on the other side of -3, it's just green. So my feasible region, that is my solution set, all right? So it's just got to be right here in this zone. So if I wanted an interval that represents that zone, well, first of all, both the blue and the green are headed to -infinity. So that interval goes all the way till -infinity. And then as it's coming back towards the right, it's going to stop at -3, okay? At -3, it's an open circle, right? So we have to use a parenthesis, right? Because remember that it needs to satisfy both inequalities. So even though it satisfies the green one, right, -3 is less than 5, right? Right here in this situation, -3 is less than 5. It doesn't make this one true because -3 is not less than -3, right? That doesn't quite work. So since it only counts for one inequality, we do not include it into both, all right? So then around infinity, it's always parentheses anyway, all right? So there it is. That's the you try problem for today. I know it was a little bit tricky, but I wanted to make sure that you saw a different way that intersections happen, right? They don't always just happen in the middle, okay? All right. Any questions on that? Some of you had like, oh moments, which is good, okay? All right, so let's go ahead. We're almost done. Go ahead and give yourself a point. How did you do? 4, 3, 2, 1, or 4, 3, 2 or less? And, right, we got the sandwich situation going on. So we have an and sandwich. If it's an and, we are looking for intersection, right? Eventually, when we look at the graphs, we are going to try to find an intersection, an overlap, all right? Now, why is it oh, screen is stuck? Is my screen stuck? Hold on, give me a sec. No? Okay, hold on. Let me, just in case. And let me start over. Okay, can we all see example 4 now? Yes. All right. No? Still no? Okay. If it's stuck on your screen, yeah, just try leaving and coming back in. Hopefully it will. All right. Okay, so here we go. We're going to treat this, right, like we did in the previous problems. We're going to try to get this x or this a by itself. Okay, so let's go ahead and do that. First step would be to get rid of 58, right? So we want to get rid of 58 first. By doing so, we have to subtract it to all three sides. Okay, so we subtract by 58 to all three sides. That's gone. Now we have 2a less than or equal to negative 8 minus 58 will give us negative 66. And then on the other side, negative 58 or negative 6 minus 58 would give us negative 64. Okay. All right. We want to get a by itself, right? So let's divide both, not both sides, all three sides by 2. All right. So we get a is less than or equal to negative 66 divided by 2 will be negative 33. On the other side, bring down my inequality. Negative 64 divided by 2 is negative 32. All right. It's because, just like we learned last time, right? Just because you had an inequality doesn't mean that the shaded section always happens in the middle, right? So we need to be careful about how we graph this. Take it step by step, all right? So let's take a look at this first one, right? That first inequality is basically saying we have negative 32 is less than or equal to a. We want a on the left side so that we can always start by reading the variable first. So a is actually negative 32 on the right side. And then since this inequality was pointing to the negative 32, make it point to the negative 32 again. All right. So really what we're saying is that a is greater than negative 32. All right. That's our first inequality. The second one is right here. Okay. We have a is less than or equal to negative 33. And that one is already in the position that we want it in. So that's good. So let's go ahead and graph, right? And let's see what's going on here. Remember that with an and problem, we are looking for the intersection. Where is it shaded, right? Where do they both overlap? All right. So starting with negative 32. And first of all, let's talk about negative numbers, right? Because if this is 0 over here, the negative numbers get bigger the further left you go. So from 0, you would have negative 32. And then further to the left would be negative 33. Okay. Walking to the left from 0, you would hit negative 32 and then negative 33 after that. All right. So if we're at negative 32, right? Negative 32, I have a closed circle there. And A is what? And where should we shade? To the left or to the right? To the right. Let's go right, right? A greater, we want greater, numbers are greater to the right. Okay, now the next one, right? A is less than negative 33. I have a closed circle here. And then we want to go left. Yes, right? To the left. All right, now, what's the problem? I'm looking for an intersection. Exactly. They don't touch, right? They don't intersect. There's no overlap between green and red. So if this answer is asking me for the intersection and there is no intersection, what do we say? Is there any number? Exactly, right? No solution. There is no way that a number can be greater than negative 32 and less than negative 33 at the same time, right? Just not possible. Okay, so oh, we got some screen issues. All right, give me a sec. Let me try this one more time. How about now? Is that better? Okay. All right. So no overlap, no intersection. Remember, that's the key thing, right? It's not just an and problem. It's that it's an intersection that we're looking for. Okay. So that's key. You have to understand that. And because there was no intersection, right? No intersection, then we can say no solution. And there's no solution, so there's no interval, right? We won't have an interval because there's nowhere where both of those graphs overlap. All right. So that is essentially our special case problem. I wanted you to see that that's also a possibility and that happens sometimes. All right. Okay. Let's wrap it up for today. Give me a second here.